All right, what we have here is a model of a V2 rocket. It's 1/6 scale, and this is an actual real high-powered rocket that's designed to fly with an M motor with about 200 pounds of thrust. This was built by Joe Hinton, a friend here in Boulder, Colorado, for his level 3. The high-powered rocketry in amateur rocketry are designed to fly using solid propellant based upon ammonium perchlorate. But if you look at the top here, the actual V2, where this line was where the warhead occurred. And this section here is where the gyroscopes and the radio control area and the compass would cause for the navigation that would control the rudders. This section down here is where the alcohol tank was located, followed down here by the liquid oxygen tank. On either side of this, they had pumps on either side that pumped the fuel and the oxidizer into the combustion chamber, and then of course going out the nozzle to the back. They basically made this 41-foot long rocket that only 1/5 of it was actually had any kind of a warhead in it. The rest of it was part of their guidance control. The over 2/3 of it was combined with the liquid oxygen tank and the alcohol tank. And there was 2 pumps. So each pump would pump the fuel at the correct mixture and would dump it into the combustion chamber where it was ignited. And then the compression of that going through the venturi created a significant amount of thrust, enough to launch the rocket. And the guidance system on the V2 was a very simple approach. They just used a compass heading that they would aim toward London. And once they got, and based upon the amount of fuel that they put into it would determine the range. So once the V2 took off and it arced over, it would basically fly until it reached apogee, where the engine shut off and ran out of fuel, and then it would fall to Earth. And it wasn't very accurate, but it was enough that they created a lot of devastation and havoc within London. The guidance system, based upon a compass heading, was controlled by 2 different rudder systems. One was on the fins, and the other one was right by the nozzle. So the fins is something we're more typically like on an airplane aileron or a rudder. But the ones that was coming out, it was kind of a novel approach at the time, was that they actually put a rudder within the thrust of the rocket engine itself. And so as the blast was coming out through there, they could adjust it. And that would had a quicker response time than it would be with the rudders that were located on the fins. But by far, the fins give most of the stability to any rocket. As I just mentioned about the V2 rocket and how they determined the trajectory and where it was going to land, the German engineers actually used a slide rule. Like this is a replica of one that was actually taken, one that was found at the Peenemünde Army Research Center in Germany. Basically, the German engineers would set upon the amount of fuel that they would be loading up on the rocket on here, and by adjusting the slide rule, they would actually be able to determine what the range, downrange where the rocket would land within a very close approximation. And I'm not too sure if that was 50 kilometers or 100, but generally they weren't that accurate as far as where they fell.